Welcome, everyone. I'm Henry Calvert from the GSMA, and I have the honor to moderate this session to bust the myths of achieving a hyper-efficient, massive MiMo 5G platform based on OpenRAN, COTS hardware, and cloud-native principles. Operators are desperate to monetize to the max their spectrum assets, and it's clear the demands for data-rich services which will require the economics provided by a massive MiMo-fueled 5G platform. But can this be delivered with a special AI mixed concoction of OpenRAN, COTS hardware, and cloud-native principles? Here to discuss this, I have three of the most exciting leaders in the infrastructure industry today. Firstly, Kuntal Chowdhury, Senior Vice President of AI and Analytics at Mavenir. Ponch Chandrasekharan, Director of 5G Carrier Infrastructure at ARM. And finally, Soma Velayutham, General Manager AI and 5G at NVIDIA. Welcome to you all.
Thank you, Henry.
Right, let's get started. Kuntal, you're opening the first question. What are the benefits and challenges of using COTS and programmable hardware in a 5G network?
Great question, Henry. Thanks for the introduction. And I'd like to begin by saying that RAN has been built with custom hardware for ages for various reasons. There are some benefits, but there are more serious drawbacks, such as lack of flexibility. As we prepare the network to serve 5G services heading towards 6G, the flexibility of the system to be dynamically programmed is extremely crucial to support ever-changing usage patterns and many emerging use cases, matching the speed of internet. We started rethinking, and we are rethinking the design of RAN. And that's where, when you ask me what the benefits of COTS is, that's where the key benefit lies. The all-important flexibility with COTS hardware. And I'll explain that more. Besides the flexibility that COTS provides, it also provides more benefits, such as the ability to run plethora of applications, practically all applications. Why is this important? Because the custom hardware-based RAN cannot do that. And as we see the importance and emergence of the edge compute, we really need to think of multi-tenancy. Multi-tenancy is a way to build the next generation edge, how the next generation services will be delivered. With a COTS-based RAN, we can do that. And it also provides a way to virtualize the infrastructure, which in turn provides significant cost benefits. But the most important thing that COTS provides that I haven't mentioned so far, the RAN domain has been plagued by vendor lock-in. Handful of vendors around the world lock this massive market for their benefit. And there's no way you can innovate besides only them innovating in the space. With COTS, we change that completely. We bring innovation from any corner of the world. But let's talk about some challenges. As you mentioned, challenges exist for us to realize this goal. Some of the challenges are intrinsic nature, because the general purpose hardware is not really built for RAN. Oftentimes, we find that there are rooms for improvement for, say, thermal management. Because these edge compute devices are not really typical data centers, thermal management becomes extremely important for us to deploy this next generation RAN, COTS-based RAN at the edge, which also has extreme good handling of the thermal of the overall solution. Other one challenge that we need to address is energy footprint, energy consumption at the edges. And as we develop more and more RAN systems, more and more layers of RAN, more and more compute resource requirement, this whole system becomes very energy hungry. We have work to do to reduce energy footprint. And from the system perspective, there's a tendency to implement the RAN system, which is very compute intensive, which requires hardware acceleration, to implement this as sideways hops between the CPU resources and the hardware accelerators. To implement such systems, we need to do more inline processing. These are the challenges I would say that we need to address. But another important thing I would like to also mention that we are moving the industry from one kind of vendor lock-in with custom hardwares into another kind of vendor lock-in with only one dominant compute supplier in the general purpose compute, at least in the ORAN or Open RAN today. That's a challenge we got to address as an industry.
Excellent points, Kuntal. Stepping back a little bit, right? So, I mean, like if you look at 5G itself, 5G introduces a number of new paradigms that compared to the previous generations of wireless technology. Orders of magnitude higher performance for throughput, latency, and the number of connected devices, which means that this spawns a whole new set of applications. And to your point earlier, Kuntal, that this invariably ties the network with edge compute, right? So, and another thing that's been like accelerating in the recent years is the innovations around CloudNative, which extends to the wireless technology, where you have a number of functions that are essentially software driven or software driven rather than custom hardware driven, and the efficiencies of scale you can achieve with a cloudified infrastructure, to your multi-tenancy point, and the software-driven innovations in a cloud infrastructure certainly makes the COTS-based implementation very attractive for the next generation of networks. So obviously there's a ton of data growth, data processing that needs to happen with 5G and 6G. And the key question is this, right? So how are you going to handle this orders of magnitude performance with a power budget that's really comparable to the previous generations? And you touched upon, these are equipment that's not going to be sitting in like data centers, right? You cannot put an air conditioner everywhere. And so especially as it gets to massive MIMO type of deployments with beamforming, beam steering, how are you going to handle that, right? And like compute is definitely going to be a balance of CPU with accelerators, especially as you get closer to the radio, right? So so power obviously is a big concern, right? So if you open any base station today, the odds are that it's going to be based on our ARM CPU, primarily because of that. And this will extend to virtualized implementations of the network for the exact same reason. And so if you stepping back, if you look at the drivers for COTS-based implementation, efficiencies of scale in the context of edge compute and the cloud infrastructure, flexibility as technology and use cases continue to evolve, and the fast innovation that's possible by enabled by software innovation, and the heterogeneous nature of compute itself, right? So these are going to be primary driver with the power efficiency as a key challenge that we need to tackle.
Yeah, these are good points. Firstly, thank you for having me here, Henry and the ARM team. So those are good points by Kuntal and Panch. I would add to that, programmability really, in some ways, it means software defined, right? And why do you need software defined? If you look at the amount of in 2G, the amount of software that was written in 2G, the number of line codes versus the number of line codes in a base station in 5G, it's exponential. The amount of software that a base station has or a 5G infrastructure has is huge. And you need to be able to write this software flexibly, the rate of change, how fast you can implement features. 3GPP release 15, 16, 17 keeps evolving very fast. And the ability to implement these features at speed and at quality and innovation within that. So you really need to, I don't think anybody would deny that software defined is not required. The idea, I guess, it's really how do you get there in the most efficacious way. So software defined equals to agility, flexibility to implement features. The other benefit is it's not about implementing the feature one time. With the complexity and the number of line codes implemented, there are going to be bugs. There are going to be features that's not going to be working. How do you troubleshoot and debug this? The whole software industry has moved to the CI/CD concept, continuous integration, continuous delivery. These are things that can be implemented when you have a software-defined platform or a programmable platform. It's not easy to do CI/CD in an ASIC or a purpose-built bespoke hardware. So these are two reasons why programmable is very important going forward. When it comes to COTS, really COTS means you can abstract your software from the hardware layer, right? And that means you can benefit from generation to generation in terms of your price performance and watt performance, power performance. So by abstracting the software from the underlying hardware, you're able to benefit from this massive growth and improvement in the hardware layer without having the price to re-implement your software features. So I think the combination of these two is pretty exciting. When it comes to challenges, obviously, as you go to a cloud native and software defined, there are some challenges, for example, security in Kubernetes layers and implementation and so on. So, but these are things that are being acknowledged and addressed by the cloud and software community, how to make sure that the Kubernetes and cloud and containers are as efficient and secure as the bespoke architecture. So I think it's a known challenge, but it's a challenge that's being well addressed, and I'm confident we'll get there.
So that's great. So the building blocks of the COTS 5G infrastructure, hardware extractability, flexibility, and performance are all coming. Most important thing is the programmability of the features and the speed of the releases that we see of those releases. And this just shows that these challenges can be overcome. I always remember building networks when I was there. You know, we put a 2G box in and then we'd rip that out and then put a 2G and 3G box in and then rip that out and put a 2G and 3G and a 4G LTE box. And the CFO was getting really annoyed with me. He was saying, can I not reuse this hardware I've already paid for again and again and again? So that's the practicality of it. And it's really great now to see that the standards are taking us to that flexibility where we can actually use those hardwares. But it is an ecosystem. Open RAN solutions are an ecosystem play. Kuntal, how do you see that coming together to enable deployment-ready solutions? How do you see this approach set up the future evolution of the networks?
Thanks, Henry. As a proponent of vRAN for over a decade now, I've seen this ecosystem of Open RAN, which is a successor of vRAN or virtual RAN, Cloud RAN, grown into a quite a vibrant one with many vendors and system integrators. And this ecosystem is driven by the key operators around the world, which is also a very good sign that operators are keen to adopt this into their network. What these operators are doing, they are conducting proof of concepts and trials around the world. And some of them actually deployed commercial Open RAN systems in major markets. And some are coming up, even in the US. So when you say, what's the status of this ecosystem and whether this is deployment ready, I would say, yes, deployment ready Open RAN solution already exists. We have to fine tune it. What the operators are doing in this space, they are familiarizing themselves with very new way of procuring, because this is disaggregated. They can't get it from one source. They have to work with a number of vendors. Integrating the solution requires a lot of effort from their part, which they haven't done it for years. And how they actually run this new domain of cloud native Open RAN of multi-vendors. But the ecosystem is quite vibrant, and there are many players who are actually making this happen. There are some challenges, of course, as I mentioned in earlier statement. One of the key challenges that I see that we need to address is that we need to enable more general purpose compute choices, such as GPUs and ARM in this ecosystem, which are not dominant today, but we have to really make this happen. And this is why Mavenir is collaborating with NVIDIA and ARM, our partners, to build a next generation COTS-based Open RAN for massive MiMo. And I'll talk about why this solution that you're building is for future generation RAN. The RAN network, as you see today, supports only a few use cases, but as we evolve and move forward into the future from 5G to 6G, there are numerous use cases that are coming into this domain for us to support, such as autonomous vehicles, drones, many sensors from IoT domain, computer vision applications, mixed reality, and this changed working force, which works remotely from home. To support this diversity of use cases, the network must be fully programmable and adaptive. In my honest opinion, Open RAN is the most promising way to build and evolve the next generation RAN.
Yeah, I think it's quite ironic. We talk about Open RAN ecosystem, and because this industry is the industry that's led the way in standardization and openness. I've not known of any other industry that kind of moves generation to generation every 7 to 10 years. We've successfully evolved from 2G to 3G to 4G and now 5G. This is a fantastic achievement for the industry. And the benefits of standardization, we can see how we've penetrated. Mobile phones have become part and parcel of everybody's life. And that's because of the openness, the standardization that GSMA brought across. We're just taking this openness to the next level rather than at a system level. Now we are taking it to a component level or a network function level and enabling more players to participate and also create a very vibrant and competitive landscape that enables innovation.
Completely agree with both of you. Open RAN certainly democratizes the implementation of RAN, which brings in many more players. In fact, like the momentum is actually in pretty good. Deloro, the analysts, they believe that in the next 4 to 5 years, the total RAN spend based on virtualized implementation is going to touch 15%, and they're getting even more bullish. And we can see that in the news that's coming around, right? So, and ecosystem most definitely plays a very crucial role in enabling this. And the ecosystem is coming together really well, to Kuntal's point. In fact, earlier today, ARM CEO Simon announced the ARM 5G Solutions Lab in partnership with system integrator Tech Mahindra for the ARM ecosystem to come together, stand up deployment ready solutions for small cells, distributed RAN, cloud-based RAN, etc., to collaborate and build most optimized solutions based on use cases that we talked about, and also drive innovations for next generation of designs. And obviously, needless to say, I'm super excited about the collaboration with our partners here, NVIDIA and Mavenir.
That's great to hear. Totally see that as the RANs sort of the architecture is disaggregated because virtualization has allowed that. In our industry today, we've seen a lot of consolidation of those boxes. I remember when I used to put 2G in and I had a BTS, there was an ABIS interface that was open. I could have multiple vendors on that radio head, and that would actually interface back openly to a base station controller, a BSC. And it's really good, as Soma says, the standards are there to ensure that there is disaggregation, which brings up the opportunity of securing up the supply chain. But also, we actually see there are new use cases. I mean, data is so prevalent, but it's used by different aspects around the network. And therefore, you need to be able to distribute the processing units that you actually need to actually serve up the relevant amount of processing and storage that you actually need at various different points in the network. That's where the benefits come from. So it's very exciting that this could be done from a standardized point of view, as Soma was actually saying. And the operators are looking forward to that, to have the flexibility of applying their use cases anywhere in the network. Now, there is a school of thought, though, that you can only use purpose-built computers, ASICs, for the physical layer, where the radio actually happens and where the communications happens. Soma, why do we have to do this instead of general purpose computing today, considering the challenges for competitiveness with energy consumption, performance, and scalability? Is the GPUs good enough to support the physical layer?
Yeah, so this would be probably, hopefully, the myth, Henry, we can bust at the end of this session, is GPUs are more than capable. In fact, probably the best way to build a physical layer in a 5G vRAN. So let me share some insights on, if you take a G node B, a 5G G node B, in a 44R low-end configuration, about 1/3 of that physical layer, 1/3 of the compute is based for FEC processing, layer 1, FEC forward error correction processing. 1/3 is for the algorithmic part of the layer 1, and the other 1/3 is for layer 2 and above. So and that's for the current configuration. As you move up to a massive MIMO layer, the amount of MIMO being a spatial multiplexing problem, the amount of compute goes up exponentially. So when you go from a 4-layer MIMO to a 16-layer MIMO, the compute goes up it's more than 4x. It goes up like 40x. So when you have the huge amount of compute, and MIMO as I said, is a spatial multiplexing problem. It's a parallel processing problem. So GPU will be extremely efficient in solving this parallel processing, and it'll be very efficient. In fact, I would go further to say that in terms of compute per cell, GPU-based processing would be probably the most efficient in terms of solving this problem. So with that, I believe that GPUs are probably the best way to solve the problem of the future. And it's also going to give you the scalability and programmability as you go forward.
If I may jump in here, the use cases of yesterday, such as voice, messaging, and basic data connectivity, are not very demanding on the network. And there's also no rapid change in these applications that are basically delivered to the over-the-telco networks. These applications are not driving MIMO or massive MIMO adoption in a big way. If the world stays on these applications for the next few decades, yeah, sure, we can keep building the way custom hardware is being built to build these existing RANs. But that ain't happening. On the contrary, we see that the rate of change and the number of applications that I mentioned before, and the usage behavior pattern changing is accelerating. Going forward, to address this changing world needs, the operators, as you mentioned, Henry, as well, that for every generation, the operators need to forklift their hardware from 2G to 3G to 4G. There's no reusability. And I'm not talking about between the generations of these wireless systems, but within the generation of wireless system, we will see usage pattern change of applications that are completely changing the way we deliver services. That means what? That means the operators need to deliver, actually upgrade the network more frequently, and much more frequently than what they are doing today. For each of these iterations, they have to change their hardware, and which will require forklift. They will lose billions of dollars in CapEx and OpEx.
Yeah.
They also need to deliver features faster. So to address these things, there is no question in my mind that we have to look at implementing RAN in a different way using COTS.
Right. So I want to add one more thing that I probably missed earlier is when you talk about physical layer, currently physical layer is pretty much a heuristic algorithm implemented. Yeah. As I said, GPUs can be implemented in a very, GPUs can do a very good job as you go into MIMO layers. However, the future is also implementing this in AI. Many of these functionalities in layer 1 and layer 2 will be implemented using AI, beamforming, for example, beam guidance. So all this with the combination of having AI and parallel processing, we're going to have an extremely efficient compute with the GPU for physical layer.
Yeah, I'll just add just a little bit to this. Power efficiency is again going to be power and performance scalability is going to be key. So in this case, the way I look at it is like the combination of the growth of capabilities of 5G, edge compute, and the AI being a key technology to enable not only network management, spectrum management, but also application management. This is where the general purpose compute paradigms become really attractive here. Again, power management is going to be key here.
Sure. I mean, what you're actually saying is really interesting news for the operator, because the operator has all these new demands coming towards them in a data-centric world. They don't know the services. They don't know the quality of service they actually have to provide. They have to react instantaneously in real time on how to actually serve what the customer actually needs at this point in time. That's going to take a level of intelligence we've never seen before. Kuntal was mentioning before, we used to provide voice and SMS services, totally different now. The data services are coming from different applications, whether it's AR, VR, how much processing needs to be done closer to the edge, phenomenally different. That's going to have to be very predictive, and AI is quite key to being able to solve and maintain the performance for an operator. Never mind the performance of the infrastructure, the performance and the experience that the customer is going to get. Finally, gentlemen, if you had one wish to all the developers out there, what's the single takeaway from this session you want the ecosystem to remember?
Yeah, let me go first. The hardware and the platforms are ready. They are efficient, and they can be also future-proof with AI. So I would like to invite the developers to come and start working on this platform as an ecosystem and to build the future together.
I'll add to that. The ecosystem is growing and vibrant. Power efficiency is going to be key. The deployment modes based on like COTS hardware, cloud-based implementation is all ready. And I invite the developers to start developing based on power efficient ARM-based hardware.
I would say that developers, please use this Open RAN as your open slate. Think outside 3GPP and build something unconventional and new, because that's what the Open RAN is for.
Thank you, Kuntal, Panch, and Soma. Extremely insightful and clear collaboration together. There you have it. You can have a hyper-efficient massive MIMO 5G platform based on Open RAN, COTS hardware, and native principles. Myth busted.
Thanks, Henry.
Thank you very much. Thanks, Henry.